नमस्कार, स्वागत है आपका विज्ञान सर्वत्र पूज्यते विज्ञान के प्रसार का महोत्सव के आज दूसरे दिन। आज हमारे बीच में मौजूद हैं डॉक्टर बी एल साल्वी साहब। बी एल साल्वी साहब मैकेनिकल इंजीनियरिंग में एसोसिएट प्रोफेसर हैं कॉलेज ऑफ टेक्नोलॉजी इंजीनियरिंग में। इसके अलावा वे हेड डिपार्टमेंट भी हैं। आपको करीब 20 वर्ष का टीचिंग, रिसर्च एवं एक्सटेंशन एक्टिविटीज का अनुभव है। आपने कई जर्नल्स में अपने रिसर्च पेपर्स जो स्कोपस इंडेक्स के हैं, एसआई इंडेक्स के हैं, उनमें आपने छाप रखे हैं। आपने कई कॉन्फ्रेंस करवा रखी है। आपने कई प्रोजेक्टों, रिसर्च प्रोजेक्टों पर आपका कार्य चल रहा है। हमारे बड़े गौरव का विषय है कि आज वे हमारे बीच में हैं। इससे पहले वे अपना व्याख्यान चालू करें, हम सबसे पहले कार्यक्रम की शुरुआत करते हैं सरस्वती पूजन से। मैं निवेदन करूंगा डॉक्टर बी एल साल्वी साहब का, वे हमारे बीच आकर मां सरस्वती के आगे दीप प्रज्वलन करें। हमारी भारतीय संस्कृति में रिवाज है कि जब भी कोई अतिथि आता है तो हम उसका पहला स्वागत करते हैं। मैं आयोजनकर्ताओं से निवेदन करूंगा कि बी एल साल्वी साहब का हम स्वागत करते हैं। हमारे लिए बड़ी खुशी की बात है कि आज हमारे बीच में डॉक्टर बी एल साल्वी साहब मौजूद हैं। जैसा कि मैंने शुरू में बताया था कि बी एल साल्वी साहब प्रोफेसर हैं मैकेनिकल इंजीनियरिंग के। आपका जो मुख्य विषय है वो है मेका इलेक्ट्रॉनिक्स। आपने इस पर कई प्रोजेक्ट संपादित कर चुके हैं और वर्तमान में भी आप डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी, गवर्नमेंट ऑफ इंडिया के एक प्रोजेक्ट पर कार्य कर रहे हैं। आपने कई रिसर्च पेपर्स कई अच्छी अच्छी जर्नल्स में आपने प्रकाशित किए हैं। इसके अलावा आपने कई कॉन्फ्रेंसों का आयोजन किया है, कई वेबिनार का आयोजन किया है। वे कॉलेज ऑफ टेक्नोलॉजी इंजीनियरिंग महाराणा प्रताप यूनिवर्सिटी ऑफ एग्रीकल्चर एंड टेक्नोलॉजी के एक बड़े विद्वान एकेडमिशियन हैं। बड़ी खुशी की बात है कि आज विज्ञान सर्वत्र पूज्यते के इस मौके पर वे हमारे बीच में हैं। मैं स्वागत करता हूं और उनसे निवेदन करूंगा कि वे हमारे छात्र छात्राओं को ज्ञान से लाभान्वित करें। सर।
धन्यवाद। धन्यवाद डॉक्टर विक्रमादित्य दवे साहब। आज खुशी का दिन है कि इस विज्ञान सर्वत्र पूज्यते प्रोग्राम के अवसर में मुझे आमंत्रित किया गया और इस अवसर पर इस प्रोग्राम के प्रथम प्रवक्ता के तौर पे मैं आपके समक्ष सतत विकास के लिए मैकेनिकल इंजीनियरिंग में उभरते रुझान, इंजीनियरिंग एमर्जिंग ट्रेंड्स इन मैकेनिकल इंजीनियरिंग फॉर सस्टेनेबल डेवलपमेंट पर अपना प्रेजेंटेशन प्रस्तुत करूंगा। So, before we start synchronizing the science and engineering, let us ask certain questions to ourselves. क्या साइंस इंजीनियरिंग के लिए जरूरी है? क्या हम बिना साइंस के आराम से कंफर्टेबली रह सकते हैं? अगर नहीं तो क्यों? क्या साइंस हमारी बेटर लाइफ के लिए मदद कर सकती है? साइंस का हमारे डेली जीवन में क्या महत्व है? क्या साइंस अलोन हमारी सोसाइटी को सर्व कर सकती है? ऐसे कई सवाल हमारे जहन में हैं, हमारे दिमाग में, और उनका सवाल जवाब करने के लिए हमें कुछ चीजें समझने की जरूरत है। तो इसी परिप्रेक्ष्य में आज हम डिस्कस करेंगे कि मैकेनिकल इंजीनियरिंग किस तरह से साइंस के साथ जुड़ती हुई और किस तरह से हमारी डेली लाइफ को, हमारी सोसाइटी को, हमारे नेशन को और हमारे विश्व को एक अच्छी दिशा में ले जाने के लिए महत्वपूर्ण रोल अदा कर सकती है। तो साइंस कई तरीके से इंजीनियरिंग एंड टेक्नोलॉजी में अपना महत्वपूर्ण योगदान दे रही है। साइंस एंड इंजीनियरिंग दोनों मिलकर के हमें कुछ नॉलेज के साथ, कुछ गणित के साथ और कुछ तकनीकी के साथ जब इसका समन्वय हम करते हैं तो हमें साइंस एंड इंजीनियरिंग स्ट्रीम मिलती है। और यही साइंस एंड इंजीनियरिंग स्ट्रीम जो हमारी सोसाइटी को आगे बढ़ाने के लिए, सोसाइटी को कंफर्टेबल बनाने के लिए महत्वपूर्ण भूमिका अदा कर रही है। So, coming to the engineering side, where the mechanical engineering is playing a very vital role, either it may be a soft engineering where software can be developed, but softwares are being utilized for certain purpose through the hardware only, and that hardware is developed through the mechanical engineering. So we have some terms like mechanical engineering, internal combustion engines, mechatronics, robotics, electric vehicle, 3D printing, challenges with 3D printing, IoTs, MIoTs, renewable energies, where the energy generated comes from the nature and it is regenerated. We have certain terms like green energy, which leads to the sustainable development of energy. So coming to the mechanical engineering, let us have a brief introduction to it, and let us look at the consequent development. So we can start from the ancient to the modern era, where there is a development path, and this development path in mechanical and human life started with the incorporation of will, where you can see the sequential development of wills from the very basic to the advanced level. Then we are moving toward the development of other advanced gadgets, where you can see the helicopter, you can see the aeroplane. Sixth slide. Here we can see the advancements. So looking at the advancements and the various levels, now we can see we are moving from the simple wheel to the advanced rocket technology where the mechanical engineering is playing a major role. You can see the role of drones for the aerial surveillance, for the transportation of lightweight goods, for the picking certain components humanlessly or remotely controlled. You see the use of drones in army, use of drones for the agricultural activities. So in this way, the lot of involvement of science and engineering is coming. When we look at the transportation sector, we can find the role of the locomotive train where the steam power was mainly utilized for transportation, and now we are moving toward the bullet train. Here again we can see the role of science and engineering, where initially the manual power or animal power was being utilized for certain agricultural activities, and now we are using the machine power where the mechanical engineering playing a role. Here we can see the steam engines moving toward the diesel generator sets for power generation, and now you can see the internal view of the working of internal combustion engine, where a lot of science and engineering is involved in this, and ultimately we are leading to the development of mechanical power and then the electrical power. See thermal power plants moving toward the nuclear power plants. So looking at these various areas, we are having some streams like thermal engineering or design engineering, manufacturing engineering, additive manufacturing, production and industrial engineering, power generation, mechatronics and robotics, mechanized Internet of Things. So looking all these things, now let us move toward the advancement part of trends in mechanical engineering, where I will be taking the additive manufacturing and 3D printing. So here, let us begin with the 3D printing. So let us come to know, are you aware about some terms like design innovation or creative design, fast moving consumer goods, product development, and all these things require rapid development of the product, which can be done through the fabrication or through some machining process or through casting process. And in all these things, the advance now we are having, which is the additive manufacturing, and that can be done with the help of some kind of 3D printers. So here you can see what is additive manufacturing. This is basically a technology which supports the sustainable rapid development of personalized complex design, various disruptive applications, especially in manufacturing and the medical field. You can see here, using this rapid development technology, this dedicated, customized chair is being developed for initial product development. Another component we can see developed with this 3D printing. So here we use this production technology for material addition or deposition, and we deposit the material layer by layer and get the desired geometry. Materials which can be used in the form of wire or deposition of fusion of power and the solidification. It bridges the gap from ideas and images on a page or screen, allowing for creation of those ideas, images in the physical object, that is, we say, 3 dimension. So it allows us the fast development. So this additive manufacturing basically used to build up a component in layer by position of material. So let us come to this 3D printing. This basic concept of this 3D printing is to have the 2D printed component, which is a kind of paper we are having these 2D printers. But when we talk about the 3D printer, then it required the 3D component in a CAD software, and that 3D model of the component is printed using this 3D printer, and that comes out in the form of an object. So that object prepared can be utilized for education purpose, prototyping, manufacturing purpose, or for agriculture implement, or for medical application purpose. You can see here the 3D technology where the CAD model is developed initially, and this is produced in the form of an real object. How it works? So basically we have a CAD model of the component which is to be produced. Then this CAD model is sliced in number of layers. These layers are, when sequentially deposited, we get component form, and ultimately we can have the physical prototype of the component. So starting from the soft model or CAD model, now we have reached to the actual component development, and that is the basis of the 3D printing mechanism. So this physical prototype is finished and we are getting the final product. So you can develop a complex shape components without having any complicated or complex tooling. Now there are various methods of 3D printings like fuse deposition modeling or wire arc additive manufacturing or selective laser sintering, powder jetting, stereolithography. Apart from this also we have the other methods based on the material used or different price points, different user points like parts or components, or we are developing building blocks. So based on that we have different technology. So now how it works? So in this FDM, fuse deposition modeling, we use the wire. Is heated. Wire is basically plastic material. It is heated, and after heating, it is deposited layer by layer in a proper geometrical shape, which is controlled by the 3D printer, where the mechatronics application play a vital role. So there is a blending of the computer science, mechanical engineering, electronic component, electricals, various drives, and all together make a machine which brings the component in a physical form, and we call it a 3D. Further is we can use the multi-jetting system. We can use the 2 wires for multicolor or multi-material development of the component. We can have the another kind of wire arc additive manufacturing, where the arc is developed to use the wire and it is deposited layer by layer. So doing all these things, we require a dedicated material. These materials can be metallic material like plain carbon steel or tool steel, stainless steel. You can use the polymers like ABS or nylon or PP material, epoxies, and many more. Other materials also there like refractories like sand or ceramic waste, elastomers, conductors. And then we have good application of the biocompatible material. तो अभी के जो विज्ञान के इस समय में बायोकम्पेटिबल मटेरियल्स को यूज करते हुए हम कई तरह के बॉडी पार्ट्स हम बनाने में सक्षम हो पाए, जिनका मेडिकल फील्ड में बहुत ही महत्वपूर्ण योगदान दे रहा है, where we can replace some damaged hip joints or body parts by proper development of the component help of this 3D printing. This 3D printing basically a technology which helps in rapid prototyping, and here we use the concept like 3D inkjet printing or fuse deposition modeling or laser net shaping, selective laser melting or electron beam melting. These technologies help us, and how do we do it? So let us look at one layout of rapid prototype technology. से हमें इस टाइप का एक कंपोनेंट बनाना है. इस कंपोनेंट को बनाने के लिए सबसे पहले हमें इसका एक कैड मॉडल बनाना होगा. कैड मॉडल बनाने के लिए हमें कुछ कैड सॉफ्टवेयर की जरूरत रहेगी. इस कैड सॉफ्टवेयर्स में भी SolidWorks, SolidEdge, CTAE और AutoCAD and many others. After developing the CAD model, this CAD model is saved in .stl file, which is transferred to the 3D printer software, and this 3D printer software, which may be Acura or Blender or Autodesk Fusion 30 or Creo, this will be processing the entire STL file, and after various settings, we can convert this file into G code. The help of memory or Engg card is fed to the 3D where we can get the output component as real object. So whatever soft object was there, now that object has been transferred to the physical geometry. So that is the way of rapid prototyping we are able to develop the things. So using this technology, we are able to make many components, and the software is shown over here, which is rapid prototyping software. The help of 3D printer is required, where we can develop the physical model of the developed CAD model with the help of this printer. You can see the various applications of 3D printing in developing the building blocks as well, where complex shapes can be developed with the help of the 3D printers. This is one more example, a more professional way for developing the prototype, where we can see the entire having the different materials, and this was produced as a one-shot component in the 3D method. We can use this 3D printing in developing the dies or the various board patterns for the jewelry design, and these various complex designs can be developed. So here basically the reverse engineering is also possible with the help of 3D printing, where the soft model is developed with the help of the physical model available by scanning the component. Then this soft model is processed, and finally we can get the other physical component of this. So reverse engineering is also possible with the help of this 3D print. These are the various medical appliances where 3D printing play a major role. So now we can see how the science and engineering together is helping the society. तो हम देख सकते हैं कई तरह के बॉडी पार्ट्स, लिम्स यहाँ पे हैं, जिनको हम एज पर कस्टमर रिक्वायरमेंट, एज पर पेशेंट रिक्वायरमेंट उनको हम डेवलप कर सकते हैं और उनको रिप्लेसमेंट के लिए यूज कर सकते हैं. So that is what the beauty of the science, which is developing the concept, and technology, which is converting the science into the reality, and engineering, which is integrating the science and technology together and bringing the product as a viable product outside. So now we can see the 3D printing machines. This machine are of different geometry and different shapes depending on the utility aspect and the need of the customer. This is the way how we can make the model of the 3-cylinder IC engines cylinder block. There are some other components being produced with it. So we at the Department of Mechanical Engineering, so we are having the 3D printing machines where we can develop the different models and we can get the prototypes. This is the one physical object developed with the help of this 3D machining. Without any complex tooling, in a one shot, this was produced. Different materials can be used in a single component. This can be produced. So, looking at various advantages and making the product development in a rapid manner, still there are certain challenges and scopes available in the 3D printing, where the challenges are limited and high cost of material. So, unreliability of machines, there are some 20% rejects which can be reduced and productivity can be enhanced. Challenge scaling of technology. The 3D printing allows the development of product at small level, but when it is to be scaled up, then there are challenges. Speed or time to manufacture, yes, of course, it requires the less tooling, but develop the 3D product, it requires a longer duration. Maybe say earlier example we have seen that took 9 hours for the component development. Surface finish is one issue, then resolution of the object, and mechanical properties. The components prepared with the help of this 3D printing are having quite inferior mechanical properties. The post-processing is required, and still it is being used for the initial prototype development, making the shapes only. Some environmental concern aspects are also there with this. So, this is the one aspect of the blending of science and engineering for production point of view. Now, we are moving toward the another aspect of the science and engineering, mechanized Internet of Things in agriculture. So, Internet of Things is basically more helpful, more useful in smart farming, where a system is built for monitoring the crop, built with the help of sensors like the light sensor or humidity sensor, temperatures, soil moisture sensor, etc. And then automatically irrigation system can start. So that is the concept of IoTs we are using in the culture. But you see, Internet of Things is a kind of protocols and some communication technologies. But when you to talk about the irrigation, how the pump will be started, how much power is being developed, how the sensor is giving signal to pump. In all these things, we require the physical entity, and how physical entities are developed through the production and where the mechanical engineering play a vital role. The farmers can monitor the field conditions from anywhere with the help of this IoT. IoT-based smart farming is highly efficient when compared with the conventional approach, because in conventional approach, a manual monitoring is required, while this IoT can give time-to-time information and helps in decision making. So, making the use of this IoT and the other things together, we are having the blend of the mechanical engineering and Internet of Things. That is what we are calling the mechanized Internet of Things, which is basically the integration of Internet with machines and actuators. This MIoT have a lot of applications in precision farming, or in agricultural drones, or livestock monitoring, or in smart greenhouses, and many more areas where MIoT can be used. Here we can see integration aspect of IoT with the field and sensors. The field is having the machines, sensors, and these are getting the information through the sensing technology, and this sensing technology are giving information to the smart analysis system where a planning is done, and through this planning, when vision is required, a smart control play a role. So there is a closed loop in getting the information, processing them, and disseminating these processed information in the decision form to control the things. So there is a close relation between the internet and the physical machines. You can see here agriculture drone, the seeding robots, weeding robots, the autonomous tractors, electrical robot for autonomous spraying and harvesting robots. So having the different needs and the different applications, the systems can be developed. So here a very beautiful combination of science, engineering, technology, a blend one can see, which will be having the future agricultural scopes. So these drones are very useful nowadays, and these are helping us in many ways, like plant health indices or plant height, production, plant counting, complete cover mapping, or field water ponding mapping, stockpile or spotting reports, or its chlorophyll measurements, nitrogen content measurement, and many more applications where this technology is supporting the human for the better cultural activities. See, in drone technology, where the sensor is getting the information, through the IoT, we are passing these informations to the processing unit, where again the electronic is playing a role, and then this information is again transmitted to the drone to do something, and this drone is having sensor which is again sensing the information. The feedback loop is going on. In this way, we are controlling the things. So, alone mechanical engineering cannot work, alone Internet of Things cannot work, alone sensors cannot work, or alone electronics cannot work. So, there is a need of multidisciplinary approach for bringing out the better use of science and technology for the human comfort, for the betterment of productivity. Now, looking all these things, here if we look at this, sensors require power, internet require power, processing unit require the power, drones require the power, electricity is required, and also earlier we have seen the transportation vehicles or 3D printing mechanism, everywhere power is required. In transportation also, we are having the huge fleet of vehicles where these are leading to the emission, and one can see how the emission is coming to the environment, how it can create disturbance in our ecosystem. And sometimes a person riding the cycle also need to have the air filter. So looking at these things, now we need to shift from the conventional energy system to the advanced energy system, or say hydrogen economy system. So in the very beginning, we were using the fuel wood, then we started to shift to the coal side, and then from coal component is decreasing and the other energy sources are increasing, then we have moved to the oil utilization, and then finally we are moving toward the hydrogen application, where the future is of hydrogen. So we are moving toward the hydrogen economy, where we can have some sustainable options. Our society should survive for the longer period. We should leave something for the society or for our coming generation. For that, we should switch over to the renewable energy generation, where the fuel cell power generation or green hydrogen production. These are the emerging trends which are research, and some areas are having the good outcomes as well. So renewable energy is the energy which is regenerated from the nature itself. You can see the non-renewable versus renewable kind of thing. Non-renewable, where you are using the fuel or fossil fuel or the nuclear, where by converting it into the thermal energy, the power is generated. But in case of the renewable energy, we are dependent on the nature. We are receiving energy from the nature, utilizing it, and the one form of energy being converted to another form, and again it is being recycled. So the overall disturbance in the environment is nil. So here we have different options like solar energy, wind energy, biomass energy, hydropower, wave tidal energy, geothermal, and let us first come to the solar power generation, how this is being planned and how it is coming in picture for the renewable energy harvesting, where the farm applications are there, where solar power harvesting systems are being installed on farm. You can use the power, solar power for the sensor powering, for the farm powering, irrigation purpose, or we can use it for the different combinations. Solar energy harvesting is a good option. Then we have hydropower. So mainly the hydraulic energy or hydro energy is converted into the chemical energy, and then finally electrical energy, where the hydropower system nowadays being installed at many places where the potential is available. One can see the big view of this hydropower plant installed at the upper side, the storage water is available and it is being passed to the hydraulic turbines where the electricity is being generated. Apart from this, we are having many small options, micro hydropower systems, where one can see the local power generation. It's a kind of different innovation done by the local people and catering their need. One can see so the small hydropower system generating the electricity and it's being utilized for the decentralized manner at the local level. You can have another fish-friendly turbines like this where you can see a net is available and this is dipped in the water and this turbine will be moving and generating the electricity through the flow of this water available from this river stream. This is another way how we can harness the hydropower. There are control systems where the floating tank kind of things are available and this common shaft is being used to develop the power. Then we move for the bioenergy system. Bioenergy, there are different segments like biogas or biodiesel, biomass, where direct burning being done, and then biomass gasification. So looking at this bioenergy system, there are various supply routes and various options available to move toward this sustainable energy system development. We have the primary bioenergy, where the bioenergy can be or biomass can be collected from the agricultural waste or the forest waste or energy crops, and then these biofuels are produced by processing the available biomass or energy crop, and then they are utilized for the power generation in the power sector or in agriculture as the end user in the form of biodiesel or in the form of bio-CNG, or there is a compressed biogas. So there is a biomass life cycle and sustainability connected with this. So now there is a time to bring into the closed circuit the nature, which are the plant, sunlight, the animals, which are the part of this ecosystem, and these are consuming the biomass or the green biomass, then they are giving the cow dung, which is being utilized for generating the biogas, or if these are used in the solid form, briquette form, biomass gasification is done, and then that processed fuel is utilized for either transportation purpose or for the electricity generation, and this biofuel upon combustion converts into the hydrogen and CO2 and ultimately goes to the environment. So in this way, the biomass life cycle is completed and it leads us toward the sustainable power generation. So in every activity, there is a close relation between the science, where the science is converting the biomass, it is providing the technology for biomass into the biofuel. Engineering is supporting in this way to bring all these technologies and science principles together and then develop a tangible product. One can see here converting the agricultural residues into the bioenergy, where the large size biogas balloons are available, and from this biogas is enriched and compressed to develop the bio-CNG. Biomass gasification plants are available, which can be utilized as a power generation system and the fuel development system based on the biomass. So there is a need for sustainable development, and that is being catered by incorporating the natural resources, bringing them together, integrating them, and then harnessing the energy from those systems. So we require the context analysis where objectives and mobilization should be crystal clear. Guidelines are required from the government side for integrated national assessment and strategy development. And then there is a need for proper assessment, evaluation and response. And all these three parameters together will lead to the sustainable bioenergy system development. So in renewable and agriculture, we are doing, as an engineer, what is our role, what we can do. Development of biofuel for farm power machines can be done, or we can go for the electric power utilization like battery or solar power or hydropower using. Blending of animal and human machine powers can be done. So all together we can use the primary production feedstock for the power generation. Then there is a conversion technology, secondary step, and then there is the end use of the produced energy, where we can use it in transport or for the drying purpose or for the cooling and heating purpose, right? So all these things are closely related, and is mandate to bring all these together to have a sustainable system for energy generation. So we are moving toward the use of biogas, of biodiesel for tractors or water pumps. Electric tractors are now coming in market, electric harvesters or electric threshers, solar-based electric hybrid systems, and there is a available tractor in market completely electric based. So agricultural context being, yes, we are at the agriculture university, Mahana Pratap University of Agriculture and Technology. So we are looking the future toward the incorporation of various science and technology to the farmers' field, integrating them and bringing all these things at common platform for the investment of production and productivity. So with this, I close my session. Thank you very much for inviting me.
सालवी जी से आपका बहुत बहुत धन्यवाद कि आपने इतने अच्छे टॉपिक पर हमारे विद्यार्थियों को, खासकर विज्ञान के विद्यार्थियों को और इंजीनियरिंग के विद्यार्थियों को आपने डिफरेंट टेक्नोलॉजीज के बारे में बताया। कुछ हम चर्चा भी करते हैं सर।
धन्यवाद डॉक्टर दवे साहब।
मैं ये जानना चाहूँगा सर कि आपने जैसे बताया कि रिन्यूएबल एनर्जी का कि इसमें बहुत स्कोप है, अलग अलग जगह इसका प्रयोग है। भारत में आप इसका कितना असर देखते हैं? भारत में इसका क्या स्कोप है युवाओं के लिए?
देखिए, भारत हमारा एक कृषि प्रधान देश है, जो कृषि का काफी कार्य हो भी रहा है। इसके अंदर किसानों को इलेक्ट्रिसिटी की सख्त जरूरत रहती है और उस इलेक्ट्रिसिटी को हम सोलर एनर्जी के थ्रू करके उनको सप्लाई कर सकते हैं। देयर इज अ वेरी गुड स्कोप फॉर डिसेंट्रलाइज्ड पावर जनरेशन with the help of the solar energy, and there is a very good scope of bioenergy development using biofuels, and how the bioethanol is also, you might have heard in petrol, the 5% ethanol was being blended. Now the government of India has planned 5%. So there is a very good scope for production of the bioethanol at local level, and that can be supplied to the industries, and where the enhancement of fuel can be done. So, a lot of opportunity for the farmers to enter into this segment and to develop the entrepreneur. Apart from this, the biomass gasification is an emerging technology which is now under development for the storage point of view, and Department of research work on the production, cleaning, and storage of the biosyn gas, where we are exploring the scope for replacement of LPG cylinder with the help of the compressed biosyn gas. So there are of course very good opportunities, and one should look into this sector, and they are also supporting our Prime Minister Narendra Modi Sahab are also very conducive in this direction, and supporting common people and farmer for looking his options and developing system.
कुल मिला के मैं आपकी बात को संक्षेप में कह सकता हूं कि इतने प्रयोग हैं रिन्यूएबल एनर्जी के कि उसके साथ रोजगार के भी अवसर है, और रोजगार के अवसर है मतलब युवाओं को मौका है। और भारत में इसकी संभावना बहुत ज्यादा है।
और महाराणा प्रताप यूनिवर्सिटी ऑफ एग्रीकल्चर एंड टेक्नोलॉजी इसके कंस्टिट्यूएंट कॉलेज जॉइंटली काम करते हुए इस दिशा में काफी वर्क कर रहे हैं, और भविष्य है कि हम कुछ इस तरह की टेक्नोलॉजी डेवलप कर पाएंगे जो किसानों के लिए और हमारी चीज हैं उनके लिए भी सस्टेनेबल फ्यूल का, सस्टेनेबल एनर्जी सप्लाई कर पाए, उसके उपलब्ध है।
आपने इतना अच्छा हमें आज नॉलेज दिया, हमारे छात्र छात्राओं को और भी विद्वान जनों जो ज्ञान के लिए आतुर हैं। मैं एक और आपसे मशवरा चाहूँगा कि ये जो हम कार्यक्रम कर रहे हैं, विज्ञान सर्वत्र पूज्यते, जो मिनिस्ट्री ऑफ कल्चर, ऑफिस ऑफ द साइंटिफिक एडवाइजर गवर्नमेंट ऑफ इंडिया और विज्ञान प्रसार द्वारा प्रायोजित है, जिसका दायित्व हमारे विश्वविद्यालय महाराणा प्रताप कृषि प्रौद्योगिकी विश्वविद्यालय को दिया गया है, आप इस पहल को किस प्रकार देखते हैं?
मैं समझता हूँ कि इस तरह के प्रोग्राम के लिए हमें अवसर आते हैं, अवसर ढूंढने में चाहिए, तो अवसर आ गए हैं, उन अवसर को बहुत अच्छी तरह से हम इस विज्ञान सर्वत्र पूज्य प्रोग्राम को आयोजित करके और यूज कर पा रहे हैं, क्योंकि ये हमें हमारी साइंस को, हमारी टेक्नोलॉजी को, हमारी इंजीनियरिंग को एक कॉमन प्लेटफॉर्म पर ला करके और जन साधारण तक पहुंचाने के लिए एक बहुत ही अच्छा प्रयास है गवर्नमेंट ऑफ इंडिया का। और जो एमपीटी को ये दायित्व सौंपा गया है, जिनको बखूबी एमपीटी ला रही है, और डॉक्टर विक्रमादित्य दवे साहब का धन्यवाद कि आपने इसको लीड लेकर के काम को किया है। तो ये वास्तव में इस तरह के प्रोग्राम्स होने चाहिए, और जो ये हो रहा है ये बहुत ही बेहतरीन तरीके से इसको किया जा रहा है। और मैं तो धन्यवाद अर्पित करना चाहूँगा हमारे गवर्नमेंट ऑफ इंडिया का और हमारे प्रधानमंत्री जी का कि उन्होंने लेकर के इसको बहुत ही लार्ज स्केल पे आयोजित किया है और सभी को इसके लिए सपोर्ट किया है।
सर बहुत बहुत धन्यवाद सर, आपने इतना अमूल्य स्वर्णिम समय हमें दिया। ज्ञान देकर हमारे छात्रों को, शिक्षकों को, और मैं आपको एक बात बताना चाहूंगा कि ये ज्ञान जो आपने दिया है, ये ज्ञान केवल महाराणा प्रताप कृषि प्रौद्योगिकी विश्वविद्यालय तक सीमित नहीं है। हमने इसका लाइव प्रसारण किया है, YouTube पे इसका लाइव प्रसारण है। तो जो भी इस ज्ञान को पाना चाहते हैं वो सुन सकते हैं, और वे हमें कमेंट्स भी देंगे तो हम आप तक पहुंचाने का प्रयास करेंगे। आपने अपना स्वर्णिम समय दिया सर, इसके लिए बहुत बहुत धन्यवाद सर। हम आगे भी आपसे जुड़ते रहेंगे।
धन्यवाद डॉक्टर दवे साहब, आपने इनवाइट किया और इस विज्ञान सर्वत्र पूज्यते प्रोग्राम में अपना संक्षिप्त नॉलेज को डिसेमिनेट करने का मौका दिया। बहुत बहुत धन्यवाद, और आपकी प्रोग्राम आगे अच्छा हो, इसकी हमारी शुभकामनाओं के साथ। थैंक यू
सर। आप हमारे बीच में आए तो हमारा कर्तव्य है कि आपको इस कार्यक्रम के संदर्भ में एक स्मृति चिन्ह भेंट करें। सर, मैं निवेदन करूंगा कि प्रोफेसर साल्वी जी के लिए स्मृति चिन्ह। हमारा आज का पहला व्याख्यान समाप्त होता है। अब हमारा दूसरा व्याख्यान दोपहर 2 बजे शुरू होगा, जिसमें इंडस्ट्री से एक व्यक्ति हैं, इंजीनियर रमेश व्यास, जो एक स्टार्टअप भी चलाते हैं, वे हमारे बीच में विचार रखेंगे। तब तक के लिए धन्यवाद।